We're going to review solving a quadratic using the completing the squares technique, and I've got an equation, and I know that you can't solve this by factoring. It's not one of those nice ones. You can pause and satisfy yourself with that if you like. And I'm going to start doing this, I'm going to do this quickly because you're experienced at it. And what I'm going to do after that, maybe I'll slow down a bit for you. So we get rid of the leading coefficient. We bring over the constant. And we leave a hole because we know we're going to play around with that space. Negative 1/3. We're going to take half that coefficient and square it. So that's going to be 5/6 squared 25/9. We're going to add it to that side of the equal sign. Got to keep the equal sign true by adding it to the other side. And now on this side, we know that we're going to have a perfect square. So I'm going to write x minus 5/3 squared. But actually, I screwed up. I should have said 5/6 25/36. You caught that, right? You caught that. Not a big deal. And so this is actually 5/6. 5/6. That's this equation factored. It's a perfect square. And now what we've got to do here is fix this up. This is minus 12/36 plus 25 is plus 13/36. All right. And now you know what we're going to do next. We're going to take the square of both sides. So we're going to get x, and I might as well skip a step because, like I said, you're already pretty good at this. We've got the square root of the right side of the equal sign, 13/36, and now we're going to add 5/6 to that. So actually, there's two roots there. You know that. Like I said, I'm going a little quick because you're sort of experts. So I guess the conventional way of writing it is the simple fraction and then the irrational part. And yeah, why not? A nicer way to do this is to bring that denominator, bring everything over into one denominator. So we have 5 plus or minus the root of 13/6, and that's the solution. All right. Now is where we get to what I really wanted to accomplish, and this maybe is going to surprise you a teeny tiny bit, but something wonderful might happen, because what I'm going to do is I'm going to suggest we do what we just did all over again. Don't believe me? Look, same equation, we're going to solve it all over again. But I turned the paper sideways because I want to have room on the right. Why do I want to have room on the right? Look what I'm going to write here. I'm going to write ax squared plus bx plus c equals 0. That is also a quadratic, but we don't know what those coefficients are. They're unknowns. And watch what I'm going to do. Again, what do we do to get rolling on solving this kind of equation? We divide by the coefficient of the quadratic term. So we have minus 5/3 x plus 1/3 x equals 0. And hey, if I could do it on this side, I could do it on that side too. Why not? Divide by the coefficient of the quadratic term, and it's going to become x squared plus b over a plus c over a equals 0. Simple algebra there. Just repeating what we did here. What did we do next? Brought over the constant and left a hole. X squared minus 5/3 x. Leave a hole equals minus 1/3. And once again, since we're working so hard on this, let's just do what we did on this side too. Plus b over a x. You caught my mistake? Leave a hole equals negative c over a. We just brought it over, just like we do here. All right? Now, what did we do? We want to find something in there that's going to give this, turn this expression into a perfect square. We took half of that, 5/6. We squared it to get 25/9. 25/36. Don't want to make the same mistake I made last time. So I have to add 25/36, and I have to subtract 25/36. Now, I don't exactly have all the room that I wish I had, but we can make it work. We can make it work. What did I do? I took half of this thing, squared it, and added it over there. So here, the coefficient of x is b over a. Half of b over a is b over 2a. And when you square that, you're going to get b squared over 4a squared. B squared over 4a squared. So I'm going to add that to this side of the equal sign. Squared over 4a squared. And as usual, I have to do it on this side of the equal sign. B squared over 4a squared. All right? So, okay. Does that look a little ugly? I admit that it does. Try and do better on the next row. Now, what did we do here? We took advantage of our technique, our completing the squares technique, and we wrote this as a square of a simple expression, x minus 5/6 all squared. And we had a little bit of work to do here to clean this up. That's a third is like 12/36. Oh man, oh man, oh man, making mistakes. I fixed it. Negative 12 plus 25 is plus 13/36. All right. Now over on this side, let's see if we can just keep moving along, applying the same ideas. This is a perfect square. We should not be surprised. It's x plus b over 2a, whoops, yeah, plus, yeah, all squared. All squared. And now on the right, well, it's kind of ugly, right? What we could do is give all these things a common denominator. We could take that negative c over a. Let's just think of it as c over a for now. C over a, and that would be like ac over a squared, multiply top and bottom by a. And if we want to get that 4 in there, we got to multiply top and bottom by 4. So this c over a is like 4ac over 4a squared. And when it's negative, it'll be negative 4ac over 4a squared. And normally what we like to do is put the positive before the negative. So on the right side, we have b squared minus 4ac over that common denominator 4a squared. So the algebra is maybe a little hairy, but we're just doing over here what we do over here to solve a specific problem. What comes next? Taking the square root of both sides, and we get x minus 5/6, as you know, equals plus or minus the square root of 13 over 6. I don't mind doing that this time in one step. And then we clean up the, oh, no, let's not forget, we've got two balls in the air that we're juggling. Let's not go too far of ourselves. What if we took the square root of those two sides, then the left becomes x plus b over 2a. And the right becomes plus or minus the square root of, well, it's the square root of the whole fraction, but I'm just going to put the numerator in the root for now. Why? Because I know that the denominator, 4a squared, it's a perfect square. So when we take the square root of it, it's going to be 2a. And again, we've already talked about the need for considering both the positive and negative roots of an expression. Like the square root of 9 really could be 3 or minus 3. Same kind of thinking, just a review there. All right, and we just have to clean this up. X equals 5 plus or minus the square root of 13 over 6. And remember, that's what we got last time, so we're not surprised. And here, oh, I wish I gave myself some more room. All right, what I'm going to do is put it over there. There's room. We're going to clean this up by having x all by itself on one side of the equal sign. X equals, bring that over, negative b over 2a. Oh, and it's going to be a common denominator, just like over there. Negative b over 2a plus or minus the square root of b squared minus 4ac. And this was really what I wanted to do. I tricked you into thinking you're reviewing a problem when I'm really proving the general solution to any quadratic in the universe. This, as you know, is the way we express any possible quadratic. And by following the rules of completing the squares, I have come up with an expression that is the solution, the general solution for the quadratic equation. And a lot of times people will say that this topic was the most terrifying and heart-palpitating and sweat-inducing topic of high school algebra. And there it is.